Hello guys. Okay, honor students, this is a quick video just to explain your DNA transcription translation project. So when you get to the agenda, please scroll down to Thursday and you'll see it under Thursday. I'm just going to click the preview for now, but you can download this document by actually clicking on the link here. Okay, so the purpose of the project is for you to demonstrate your understanding of the DNA transcription translation process. I have here that the project should take you no more than a week to complete, but in all honesty, once you've kind of got it all together, it really shouldn't take you more than a couple of days, okay? So there are three parts to the project. The first part focuses on the transcription translation. Here I am giving you the code that you need to use. The first part I've already completed for you as an example so that you know what it is, that I'm expecting you to do. So here's your DNA strand. This is the transcribed messenger RNA strand. Then this is the corresponding methionine with its anticodons. Notice that my anticodons match what it says on the messenger RNA. So messenger RNA has an A that matches with U. The U matches with the A, and the G matches with the C. So when you do your anticodons, you want it to be the corresponding letters with your messenger RNA. Okay, so you're going to obviously complete all of this. I suggest that you complete this section on a piece of paper or something like that, because you're going to need this information to actually put into your project. So the letters that you're writing here is what you're going to incorporate in your project overall. So like I said, on a piece of paper, I would write down the answers to this. Notice that you're going to have 1, 2, 3, 4, 5, 6 amino acids total. Okay, so the protein that you're creating is only 6 amino acids long. Please know that that proteins are not that short. Naturally, proteins are like hundreds to thousands of amino acids long. But this is just your project, so I'm gonna have you guys doing 6. Okay, so once you complete that, you're gonna go on to part 2. In part 2, you're actually gonna build your model. Now, this is where you get to be a little creative. Obviously, because of COVID-19, you guys cannot go out and buy any supplies. I do not expect that. Use what's in your house. Be creative. At the end of the project, I have pictures of some different possible examples. This one here is showing some sort of pre-made linked pieces here. If you have Legos at home, you can probably build your model out of Legos. The second one here is just showing it right off of paper, construction paper. This is another possibility. Or you can even use food, okay? I know that this example is showing DNA replication and protein synthesis. We are not doing DNA replication. We're only doing the protein synthesis, but I put this picture in here just to show that if you have candy at home, you can build your model out of candy. So just giving you some ideas of different ways that you can build your model. It all depends on what you have available in your home, okay? So what is this model that you're going to be building? You're going to build your DNA strand and show the genetic code that's listed here. So if you notice in this image, let's see. Okay, so for instance, in this image, just as an example, you see how they're using the little gummy bears as their bases. And in here is a key that indicates what each color gummy bear is. So if, for instance, you wanted to use food to create your model, when you build it, you would have to have a key. This would be like a key to tell me what color each little piece represents. So for instance, the colors of the gummy bears here should match the code that I've given you up here. Okay, it should match. Of course, you don't have to use gummy bears. It could just be like construction paper. So obviously, if you're going to do construction paper, now in this image, they're just showing you the messenger RNA. But if you built your DNA out of paper, again, you would make sure that you have the code that I've given you. You're also going to show me a model for your messenger RNA. And it can be something like this. Again, it's your option. You're also going to be having, you also need to build a model for your tRNAs. So, again, something like this for your rRNA or your reader. Here's the messenger RNA. So you need to figure out how you want to represent the parts of DNA transcription translation by building a model of your choice. Whatever model you choose, just make sure that it's labeled and it's clear as to what it is it stands for. Okay, so again, if let's say you build with Legos and it's something like this up here, make sure you have some sort of a key that tells me what the blue stands for, what the green stands for, the red, the yellow, the white, like what do the colors represent? You should have some sort of a key for that. Okay, so that's part of what part 1 is talking about here. Let me scroll up here. Okay, so your DNA strand, make sure you show me the oxyribose sugar, the phosphate, and nitrogen bases. Label the strand as your DNA and then tell me which pieces which have a key. Your messenger RNA, guys, messenger RNA looks just like DNA except it's one strand. And of course, you don't have a T, instead you have a U. So when you build your messenger RNA, again, make sure you indicate what the sugar, phosphate, and nitrogen bases. The sugar in your DNA can be the same color, let's say, as the sugar in messenger RNA, because it is really the same thing. So let's say you're doing Legos and a blue Lego, I think it's even blue, whether it be a blue Lego, is the sugar in the DNA. So blue Lego can also be the sugar in your messenger RNA. Let's say the red Lego is the phosphate in your DNA. The red Lego can be the phosphate in your messenger RNA. That can match. Even your nitrogen bases can match. So if your A up here is green, then the A over here can be green. But again, just remember that DNA has thymine, messenger RNA has uracil. So if you're doing this by colors, the T and the U obviously will be 2 different colors. But again, you want to make sure that you label it and indicate what is what, and also show me your RNA polymerase. Again, something similar as you can look here in the model. You can see how the you can see how the RNA polymerase is located here, showing how it's creating the messenger RNA. Okay. All right. You are also going to, in part 2, show me your translation. So in other words, you need to have something that shows the reader or the rRNA and your tRNA. You need to have something that shows your amino acids. And now this part, I want you to notice, you're only doing 6 amino acids. I want 4 of them to be linked as a protein and 2 not. So let me show you what I'm talking about. If you look here at this model, if you look at this model here, let me show I'll show you in a different picture. Let me pause this for a second. Okay, so here it is in the image I'm talking about. So when you build your tRNA with amino acids, do you see how some of these are already linked as a protein? Okay, in your image, I want you to have 4 of them linked. So like you would have, this is 1, 2, 3, I'm going to just add one more here, 4. Okay. And then I want 2 to be like this, attached to tRNA. So you'll have 4 that are going to be part of the protein, the polypeptide chain that's being formed. They're not going to be attached to a tRNA like you see in this picture, but then you're going to have 2 that are attached. So that's what I'm talking about when I say 4 loose and then 2 attached. So when you build your model, you're going to build it something like that. So whatever you decide to use for amino acids, make sure that you have 4 of them that are linked. They're linked just like this. And make sure you have 2 that are directly attached to a tRNA. Okay. Make sure you also show your polypeptide bonds. Okay. Excuse me, your peptide bonds, which are here and here. You see the little lines in between? Make sure you indicate the peptide bonds that are in between. Okay. All right, so let's go back to the directions. Okay. So after you get that in there, you're gonna have that translation process done correctly. You're gonna, the way you set it up should show that you understand the basics of transcription translation. In part 3, it's video time. Now you are going to record yourself describing to me the process of transcription and translation. We're going to be using Flipgrid. If you notice here where it says part 3, create a video, period 1, this is the link that you're going to upload your video. When I upload your video, you're going to record your video using this link. And then period 2, you're going to be using this one here. So when you go on, it's going to look something like this. When you click your link, this is for period 1. Here's your directions. And then this is your plus sign to start. Now, I'm not going to hit it because it's going to turn on my camera. But once you hit the plus sign, it'll give you the opportunity to start recording. You do not have to show your face. Point the camera at your model so that I can see it, and just talk me through the process using your model. So show me and describe to me what you have. That's how I'm going to grade your project through Flipgrid. Okay, here is the rubric. 20 points total for part 1. And in the center here describes how you earn the 20 points. 50 points for part 2, 75 for point 3, for a total of 140 points. Now remember, you are not uploading anything to Canvas, you're just recording a video onto Flipgrid. I will watch your video on Flipgrid and then give you your points in Canvas. Okay? And so that's your project. Have fun with it, guys. Be creative. These are just ideas. You do not have to stick to any of this. Feel free to be creative to make it any way you like. All right, guys? All right. Any questions or concerns, come see me, write me, or see me during office hours. Talk to you later. Ciao.